Welcome. In this second half of the lecture, we are going to study relationship between distribution coefficient and distribution ratio, and this relationship between KD and capital D is evaluated with the help of equation. Now once again, consider HA is the weak acid which is dissociated in aqueous phase, as HA is in equilibrium with A minus plus H plus. Is it right? So to derive the relationship between KD and D, we are going to consider a simple dissociation between weak acid HA in aqueous phase, right? So it is get distributed or dissociated as A minus and H plus. As we know that dissociation constant for this weak acid in aqueous phase can be given by the following equation, that is Ka is the dissociation constant is equal to concentration of product divided by concentration of reactant, that is K is equal to concentration of aqueous H plus ions in aqueous phase plus concentration of A minus in aqueous phase divided by concentration of HA in aqueous phase. Same equation can be modified for A minus. How it is modified? That is A minus, rearranging the equation first, that is A minus in aqueous phase is equal to Ka into HA in aqueous phase divided by H plus ions in aqueous phase. We have given the number for both equation, that is equation first gives the value of Ka for the dissociation, and same equation is rearranged, that is A minus in aqueous phase is equal to Ka into H plus HA in aqueous phase divided by H plus. That is equation first and equation second is totally related with the dissociation constant of weak acid HA in aqueous phase. Okay, this is very simple. Now I hope that you understand up till now, that is dissociation of weak acid, dissociation constant of this weak acid, and K can be rearranged, or A minus concentration can be rearranged in this manner. So remember equation first and equation second. The next slide, that is this one. Okay, then we know the equation for dissociation coefficient and distribution ratio as follows. Now we have already discussed what is distribution coefficient Kd, which is equal to concentration of HA in organic phase and concentration of HA in aqueous phase. हे इक्वेशन आपण थर्ड नंबरचं अगोदर पाहिलेले आहे. Distribution coefficient is equal to, it is the ratio of solute in organic phase to the solute in aqueous phase. Here we are taking weak acid. Organic phase मध्ये असणारे weak acid concentration, aqueous phase मध्ये असणारे weak acid concentration. This ratio is nothing but it is the distribution coefficient. ह्या इक्वेशनला आपण नंबर दिलेला आहे 3. सेम इक्वेशन कॅन बी rearranged for weak acid in organic phase equal to Kd into Ha in aqueous phase. This is about distribution coefficient. Then distribution ratio, just we have studied, that is concentration of weak acid Ha in organic phase total divided by Ha in aqueous phase in total. Same equation can be written as weak acid in organic phase divided by weak acid in aqueous phase, which is distributed, plus A minus in aqueous phase. Now see the term written as denominator, that is in aqueous phase Ha is get distributed into A minus and aqueous phase Ha in aqueous phase. So this is the equation now for distribution ratio, which is denoted by number 4. Again I will repeat the equation 3 and equation 4. Again I will repeat equation 3 and 4. Equation 3 shows distribution coefficient is equal to, where no complete distribution or dissociation is considered. It is the ratio of weak acid in organic phase divided by weak acid in aqueous phase. Same equation can be rearranged as concentration of weak acid in organic phase equal to Kd into concentration of weak acid in aqueous phase. Right? This is equation 3. Now, distribution ratio is equal to concentration of weak acid in organic phase, total concentration. Organic phase does not show dissociation of weak acid. The terms remain as it is in second equation. Remain there. Try to understand. Second, below, that is aqueous phase in total concentration, the equation becomes Ha aqueous plus A minus in aqueous phase. This is the fourth equation. Okay, 3, 4. Now we have to substitute the value of A minus from equation second to equation fourth. We get the value of equation second in the value of A is calculated. This value of A is put into equation fourth. Is that right? The equation becomes now distribution ratio is equal to concentration of Ha in organic phase divided by concentration of Ha in aqueous phase plus Ka into concentration of Ha in aqueous phase divided by H plus ions concentration. ह्या equation मध्ये, in this equation we have substituting the value of A minus from equation second. Hence we are getting the D is equal to this equation, and now to this equation again capital D is equal to, which changes we have made, that is the value of Ha is put in this equation from the relationship of Kd, that is from equation 3. इक्वेशन 3 मधली ही H ची व्हॅल्यू आपण इथे ऍड केलेली आणि त्यानंतर आपल्याला हे न्यू इक्वेशन मिळालेलं आहे. ओके, अगेन आय विल शो दिस स्लाइड slowly. That is equation 3 distribution coefficient, equation 4 the distribution ratio, Then making the changes of value of A minus into the equation fourth, we are getting this equation, and next equation is obtained by putting the value of weak acid concentration in organic phase with respect to Kd, that is from 3, equation 3. Then the next slide is this one. This is the now final equation. We are getting this. That is, equation becomes D is equal to Kd upon 1 plus Ka upon H plus ions concentration in aqueous phase. That is, numerator and denominator, upper side and lower side is divided by the value of Ha in aqueous phase. We are getting this equation. So simplifying this equation, the final relationship is that is D is equal to Kd upon 1 plus Ka upon H plus ions in aqueous phase. By simplifying this equation, we are getting the final equation, that is D is equal to Kd into H plus ions concentration in aqueous phase divided by H plus ions concentration in aqueous phase plus dissociation constant. Okay. Again, I will repeat the last slide. This one. This is the equation. Total equation, denominators are divided by HA in aqueous phase. We are getting the equation which is shown in last slide. Okay. So this is overall about the relationship between Kd and D. Okay. Now we will stop here.